Hello. This lab analyzes distance dependence of a magnetic field due to a permanent dipole magnet, and the magnet that is used in this lab is a bar magnet. The measurements are compared to predictions of Biot-Savart law equations for on and off-axis magnetic fields, and the fields are measured using a sensor on a smartphone. The procedure of the lab is that a phone is aligned with the north direction of the Earth's magnetic field, so the magnetic field of the bar magnets that's used is orthogonal to the Earth's. And with this alignment, the east-west axis which the magnet points along is laid out using either a meter stick or a measure tape, depending on your choice. And so, after the location of the magnetometer sensor on the phone is found, this is done by arranging the phone perpendicularly, finding minimum x and y values, and getting to a part where you then find the exact place on the phone in order to distance away from the magnet. The distance between the sensor and the magnet is recorded at different points, where the x component of the magnetic field is at certain magnitudes. And so, after these on-axis measurements are found, then off-axis at 45 degrees distances are recorded. So, along with the magnetic fields at the given points. And so, first off, let's analyze the on-axis relationships. The distance dependence can be represented with the equation from the magnetic field, the magnitude of the magnetic field equals k times r to the n. So the degree to which r affects b is represented with n. So in order to find n, the equation can be linearized into logarithms. And with this, and after using the data given, we can then use data to make this graph and use the linearized values with the slope equaling n, x being ln of r, and then the intercept being the ln of k. And with this, n equals negative 3.28, ln of k equals negative 5.327, and the negative, and then so the magnitude of the magnetic field is around k over r to the third, given our value of n. So the value for mu is given by deriving from the value of k. We can change ln of k into k, and then using the Biot-Savart law, we can isolate mu, and the value for mu is 1.103. And so this is now the model version of it. Here's the magnet in the center, and here are a bunch of different directions due to different observation locations. And here's the code in question, which makes the different arrows. And getting back to that, we have our values for the different values in Teslas for these different arrows. And so, given the observed values, the magnitude was 4.58 for the value at 45 degrees with a distance of 0.21 meters. The one that was just seen in the glow script had a magnitude of about 1.545 times e to the negative times 10 to the negative 5 teslas. So it's definitely obvious that the computed value is smaller. So now let's go into some conclusions. So if the experiment was not oriented to compensate for the Earth's magnetic north, the resulting non-zero x component of the magnetometer would have contributed to the net magnetic field. Thus, the relationship between the distance between the bar magnet and the sensor would have been misrepresented. The magnetic field values would have likely been smaller. And so, if two identical magnets were stuck together, the data would be skewed and most likely having higher values due to the excess dipole field resulting from another magnet added into everything. So that's it. Thank you.